Welcome to linear inequalities and polynomials, critical questions. These are questions taken from competitive exams and also some practice questions which are critical. Let's get into the problems. Yeah, the first one is let f is a function defined as from r minus 0, means real numbers without 0, to minus infinity to 1, be a polynomial of degree 2, which means quadratic polynomial, satisfying f of x into f of 1 by x equal to f of x plus f of 1 by x. If f of k equal to minus 2k, then sum of squares of all possible values of k. Okay. So what is given is f is defined as a uh, quadratic polynomial, and its domain is real numbers without 0, and the range is minus infinity to 1. Okay, and f of x also satisfies the equation f of x into f of 1 by x equal to f of x plus f of 1 by x. Okay, and f of k is given as, or f of x is given as minus 2x, minus 2k. Okay, so once you look at this one, something should strike for you. Okay, you should remember this one always. If any function defined satisfies this equation, okay, if any function satisfies this equation and f of x is a any polynomial basically, then f of x is equal to, if it is quadratic, it is equal to 1 plus or minus x power 2. If it is of degree n, then it will become f of x is equal to 1 plus or minus x to the power of n. Okay, so this you should remember. If you remember this, then this problem is very, very easy. Okay, so before going into the problem, let's see proof of this one. Okay, if this is equal, how can we get f of x equal to 1 plus or minus x to the power of n? Okay, let's check the proof first. Okay, so let's f of x is a polynomial of degree n. Okay, so it's defined something like this, and then f of x into f of 1 by x equal to f of x plus f of 1 by x. I am taking the LHS side terms to the other side and adding 1 on both sides. Okay, why I am doing, I want to factorize basically on the RHS side, I want to factorize. Okay, so this is what my equation looks like now. Okay, then I can take f of x common, then it will become f of x minus 1 into f of 1 by x minus 1, which is equal to 1. Okay, now if I call f of x minus 1 as g of x, okay, if I take g of x such that it is equal to f of x minus 1, okay, which means g of 1 by x is also equal to f of 1 by x minus 1, correct? So above equation is nothing but g of x, correct, g of x into g of 1 by x equal to 1, g of x into g of 1 by x equal to 1. Okay, so this is possible only if g of x equal to plus or minus x to the power of n. Only in this condition it is possible. Okay, any other case it is not possible. Okay, so which means that, okay, g of x equal to f of x minus 1, which is equal to plus or minus x power n, or f of x equal to 1 plus or minus x to the power of n. Okay, this is what we are trying to say here. Because it is quadratic, n is 2, so f of x equal to 1 plus or minus x square. Okay, hope you understand this proof. Once you know this one, this problem is very simple. Only thing is, one twist is a small twist which you should be carefully doing. Okay, so this is the given problem, and we know that f of x is equal to 1 plus or minus x square. Okay, so f of k equal to minus 2k. This is what is given. Okay, why this is given? Okay, it is very important to note here. Okay, so which means f of x is only 1 minus x square, because f of k has negative numbers and positive numbers, right? Because the domain of function is r minus 0, which means k can be negative or positive. If k is negative, this is positive. If k is positive, this is negative. But if you take 1 plus x square, you will never get a negative value. You always get positive value. So f of x cannot be equal to 1 plus x square. It is only 1 minus x square. Okay, by mistake you have taken both equations, then you will get a different answer. Okay, so f of x can be only 1 minus x square. So once you know this one, this is simple. F of k equal to minus 2k, which is equal to 1 minus k square. So if I write it as a quadratic equation, it will become k square minus 2k minus 1 equal to 0. I know that alpha beta are roots of this quadratic equation, then alpha plus beta equal to 2, alpha beta equal to minus 1. So what I need is sum of squares of all possible values of k. Sum of squares of root, right? Roots of k square minus 2k minus 1, which is nothing but alpha square plus beta square, which is alpha plus beta whole square minus 2 alpha beta, which is 6. That is the answer. Okay. Hope do this carefully, and this junction is very important. Even though you know this formula, this junction coming to this point is very important. Okay, so check the problem carefully. JEE main questions are always coming like a twist. Okay, next. The number of real solutions of x, y, z, t of simultaneous equations 2y equal to 11 by x plus x, 2z equal to 11 by y plus y, 2t equal to 11 by z plus z, 2x equal to 11 by t plus t. Okay, cyclical equations basically, right? So then what is the real solutions of x, y, z, t? How many solutions are possible? This is the question. Okay. Now first let's see. This is what is given. Okay. Now let's say if x is less than 0. Let's say if x is less than 0, what happens? This is 11 by x is negative, right? So y also will be negative. Okay, if y is negative, z also is negative. If z is negative, t also is negative. If t is negative, again x is negative. So it's a cyclical, which is satisfies, right? If it is positive, if x is positive, then y is positive, z is positive, t is positive. So which means x, y, z, t are all negative or all positive. Okay, this is one very important thing to note down. Okay, this will as, uh, uh, this will make sure that you get the right number of solutions for these equations. Okay, otherwise number of solutions you may go wrong. Okay, let's see. Now 2y by 11 plus 2y equal to 11 by x plus x, which means x square minus 2yx plus 11 equal to 0. This is a, let's assume this is the equation, quadratic equation in x. Then it is given that these are all real solutions, which means discriminant should be greater than or equal to 0, which means 4y square minus 44 should be greater than or equal to 0, or y is greater than or equal to plus or minus root 11. Okay, so note down this point. So if y is greater than or equal to, similarly we can take other equations and prove x is greater than or equal to plus or minus 11, same thing with z and t. Okay, so once you are at this stage, now let's take sum up all four equations. Okay, equation 1, equation 2, 3 and 4. If you sum up them, you will get 2 times x plus y plus z plus t equal to 11 times 1 by x plus 1 by y plus 1 by z plus 1 by t plus x plus y plus z plus t, which you can take this to the RHS side, LHS side, and then what you will get is final equation is x plus y plus z plus t equal to 11 times 1 by x plus 1 by y plus 1 by z plus 1 by t. Okay, hope you are with me on this. Okay, so and it is given, this information is given, x is greater than or equal to plus or minus root 11, same as y, z and t, correct? So which implies 1 by x, 1 by y, 1 by z and 1 by t will become less than or equal to, right, reverse, it will become reverse, less than or equal to plus or minus 1 by root square root of 11. Okay, this inequality will reverse because it is reciprocal, right? So if you see this one, okay, this side you have maximum value, right? This side you have minimum value. Both can be equal only at the juncture, right? Which means minimum of x plus y plus z plus t should be equal to maximum of 11 times of this one, right? This is the only possibility. Now, what are the possibilities with these conditions? Okay, one thing you can tell, let's take, it's anything greater than root 11, so let's take 3. So I will take 3 plus 3 minus 3 minus 3, right? Then 1 by 3 plus 1 by 3 minus 1 by 3 minus 1 by 3, all will be 0, 0, 0. Then 4 I can take, 5 I can take, we will get infinite solutions, right? So infinity is the answer then? No. Okay, this is where this comes. Either x, y, z, t are all negative or all positive. You cannot have 3, 3, minus 3 as a solution. Okay, for x, y, z, t. It has to be all positive or all negative, which means only possibility looking at this equation is x, y, z, t can be either square root of 11 or minus square root of 11. This is the only possibility. Okay, so two solutions are the only possible for this set of equations. Okay, hope you understand this. Next, if x square plus 2ax plus 10 minus 3a is greater than 0 for all real values of x, then the range of a. Okay, so this is a linear inequality, quadratic equation, right? Quadratic polynomial, which is always greater than 0. which means it don't have any roots. When a quadratic equation don't have roots, when its discriminant is less than 0. And when it is positive, when it is completely positive, if the coefficient of x square is positive, right? So this satisfies all the conditions here, right? Correct? So it has a coefficient of 1, x square coefficient is 1, which is positive, and this polynomial, quadratic polynomial, is greater than 0, which means it don't have roots, which means the discriminant is less than 0, right? So from the given data, right, x square plus 2ax plus 10 minus 3a is greater than 0. Coefficient of x square is 1 greater than 1, which is greater than 0. Once you know this, discriminant is less than 0. This is possible only if this is discriminant is less than 0, right? So take the discriminant. D is equal to 2a whole square minus 4 times 10 minus 3a, which is less than 0, or simplified 4a square plus 12a minus 40 less than 0. Simplified further, you will get a plus 5 into a minus 2 is less than 0, or a is between minus 5 and 2. So this is the range of a for which this quadratic polynomial is always positive, right? So a belongs to this range. Okay, if you understand by graph. Okay, so this is when discriminant is greater than 0, you'll have two roots. When it is equal to 0, you'll have one root, like this graph is. When it is d is less than 0 and coefficient of a is coefficient of x square is positive, then this is how it looks it. So we are looking at this condition now, right? So a belongs to minus 5 to 2. Okay, next. The number of solutions of greatest integer function sin x plus cos x equal to 3 plus minus sin x minus cos x in the interval 0 to 2 pi is. Okay, here this function is greatest integer function. Okay, so I hope you know what is greatest integer function. Okay, if it is 1.1, greatest integer function of 1.1 is 1. Okay, so now you understood what is greatest integer function is. Okay, so these are the options given here. Now, if you look at this problem from range of 0 to 2 pi, then it is really difficult to solve this problem. Okay, you need to consider many conditions, but simply you limit it to 0 to 2 pi and see. See, if it is multiple solutions, okay, uh, if you get only one solution in 0 to 2 pi, pi by 2, then we can easily understand how it behaves in second quadrant, third quadrant, and fourth quadrant, right? So that way you can easily see. So let's restrict and understand the problem from 0 to pi by 2 first. Okay, 0 to pi by 2, let's find the sin x plus cos x range. Okay, sin x plus cos x range is, if you know, it is minus root 2 to root 2, because 1 1 are the quotient of sin x and cos x. If you don't know that, then you can also do it this way. You multiply with root 2 and divide it by root 2, and then you can call it root 2 into sin x cos pi by 4 plus cos x sin pi by 4. Okay, this is nothing but root 2 times sin of x plus pi by 4, because this is the sin a cos b plus cos a sin b equal to sin a plus b. Okay, now the maximum of this one is 1, so which means root 2, and minimum will be 1 by root 2. So minus root 2 to root 2 is the range, but most of the angles, for most of the angles, you have uh, 0 to above 1 values possible for many angles, right? So maximum of root 2, if you consider root 2 for some more values also, you will get 1 point something, right? 1.4 it is. And if x is pi by 4, you will get root 2. If x equal to 0, you will get 2, right? Yeah, sorry, 1. So 1 to 1 by 4, there are so many values, so many angles, right? Infinite angles. For infinite angles, this maximum, this range is above 1, which means the greatest integer function of sin x plus cos x will be 1 for several angles. Okay, if you understand that, that's enough. So there are already, for infinite angles, this is possible. Now look at the LHS side. LHS side is minus sin x greatest integer function minus cos x greatest integer function is always minus 1 in range in 0 to pi by 2, because you will never get more than 1 here. So always it is a uh, negative value of 0 point some negative value, right? Negative 0 point x right? Which is nothing but the greatest integer function is -1. So once you know this, your equation which is given, okay, greatest integer function of sin x plus cos x equal to 3 plus greatest integer function of minus sin x and greatest integer function of minus cos x, okay, which is equal to 1 always. Both sides it is 1. This is -1, so -2. So 3 equal to 3 minus 2, which is 1, and this side is 1. So this is true for many angles. In the range of 0 to pi by 2 itself, it is possible for many angles, which means your solution set is infinite. Okay, you don't need to check the other quadrants now, right? So this is the solution set. Hope you understand this problem. Next, the number of values of a for which the system of equation to the power of absolute x plus absolute x equal to y plus x square plus a and x square plus y square equal to 1 has only one solution where a, x, y are all real. Okay, so there are two equations given. This is one here, okay, and the other one is x square plus y square equal to 1, which we know this is a circle equation with center at origin, and this is where the points will be 0 comma 1, -1 comma 0, 0 comma -1, as well as you will get 1 comma 0. These are the 4 points where it will cut the axis, x-axis and y-axis. Okay, so what about this equation? That is what we need to find out. So there is a y here, so take y. Okay, so this is the given equation, and y equal to the power of absolute x plus absolute x minus x square minus a, which is our f of x. Okay, now f of minus x, if you check, okay, because we need to know whether this is a what kind of equation this is. We need to understand, right, what kind of polynomial equation this is. So f of minus x is also equal to x, okay, which we can clearly see because there are two absolute values x and one x square, so sign will never change for minus x, correct? So which means this is a even function and symmetric about y-axis. Even function is always symmetric about y-axis, right? So this is even function symmetric about y-axis. Now once we know this, either I can draw a bell curve like this up or down, correct? So either it has to be a curve here, because he said this has only one solution. So they intersect only at one point. That one point can be either this one 0 comma -1 or 0 comma 1. Here upward, here downward. That is the only possibility. If it is upward here, then you will get multiple solutions, multiple cuts, right, with the circle. So you will have more than two, at least three solutions you will have. But if it is here upward, one solution. At this point, if it is downward, you have one solution. Okay. So now we know that 2 power x plus 2 power x absolute x plus absolute x minus x square minus a is the increasing upward function. You can try few numbers actually. Up to 2 to the power of 4, x is equal to 4, 2 to the power of 4 is 16, 16 and then minus 16, 4 square is 16, so 16 16 cancel, and then you will have 4 minus a, okay, so which we cannot tell it is positive or negative, but you take 5, okay, 5 onwards 2 to the power of x is more compared to x square, so you will always have positive values, okay, so it's a upward function only, okay, it is a upward function, increasing function, upward, okay, y is always increasing, so it's a upward function. Now once you know this, only possibility is 0 comma 1, okay, this is the only place where you can have a curve like this, okay, symmetric about axis. It can be anything like this also, okay, symmetric about y axis, that's all, okay, but they intersect only at this point, okay, so which means you can take that y equal to 1 and x equal to 0, then a is nothing but 0, okay, so this is the only solution possible, okay. If you want, you can also prove that 0 comma -1 is not a solution. That is also very easy. Let us prove, okay. So this is the given equation. I am assuming that it is 0 comma -1 is the solution, correct? So let's take -1, y as -1, then x as 0, then I will get a as 2. If a is equal to 2, then this is what my equation is, correct? Y equal to 2 to the power of absolute x plus absolute x minus x square minus 1. This is what my equation. And let us check. We know 2 points on the circle, right? Possible points. So 1 comma 0 minus 1 comma 0. Let's see what happens at the point. Okay. At 1 comma 0, the equation is satisfied, which means this curve is intersecting at 1 comma 0 also. At minus 1 comma 0 also, equation is satisfied. which means it has 3 solution points if it is at 0 comma minus 1. If it is intersecting here upward from here, then it has 3 solutions, which means this is not a possible answer, right? Because it is given clearly that these equations have only one solution possible, right? So this is not a solution. Only possible solution is a equal to 0, which is only unique solution. Okay. Next, n is an odd positive integer. Then the number of real roots of the polynomial, which is given Pnx equal to 1 plus 2x plus 3x square plus dash dash up to n plus 1 x to the power of n. This is a very generic equation. You can also remember actually. Need not solve it. You can solve it once and then remember. Okay. How many roots are possible? Real roots are possible. So normally for a real roots, to quickly verify, we apply Descartes rule, right? So if you apply the Descartes rule on this one, on this equation, for positive roots, we definitely get no sign change, which means there are no positive real roots. So Descartes rule always says if it is 0 or 1 roots you are getting, it is exact number. If it is any other number, you are getting any other positive integer value, okay, like n roots are possible, then it meant to say this is maximum possible. Okay, that need not be true. But if it is 0 or 1, it is always true. So positive real roots, definitely no positive real roots for this equation. Okay, because if you take any positive value of x, this will never be 0, right? This will never be 0. Any positive value of x you take, this will never be 0. So there will not be any positive real roots. Okay, that's straightforward. Now let's check for the negative real roots what happens. Okay, p of minus x, which is nothing but every alternate term is negative. Since n is a odd positive integer, you will have n plus 1 by 2 sign changes, correct? N plus 1 sign changes are possible, which means does not mean that n plus 1 by 2 negative roots are there. Okay, it meant to say maximum positive negative real roots are n plus 1 by 2. Okay, it may not be. Okay, so let's first to find out, is it really n plus 1 by 2 or something else, something less than that. Okay, so let's check. So this is my given equation. I'll just multiply with x on both sides. Okay, so this is what it will become. Now if I subtract both of them, what I'll get is p of x into 1 minus x equal to, okay, 1 plus x square up to x power n minus this only one term, n plus 1 into x to the power of n plus 1. So this is my GP. So 1 minus x to the power of n plus 1 by 1 minus x minus this term as you same I wrote. Okay, now if I take my 1 minus x to the LHS side, it will become p of x equal to, okay, 1 minus x to the power of n plus 1 by 1 minus x whole square minus n plus 1 x to the power of n plus 1 by divided by 1 minus x. If I take LCM, this is what it will become. Now you look at this one. The denominator is always positive. So this will not affect any of your sign changes. Correct? So P of x is nothing but is only influenced by the numerator, not denominator. Okay. So now you apply Descartes rule on this. This is a simplified equation, right? So if you apply Descartes rule on this for negative x, okay. So f of x is this numerator you take. If you apply f of minus x, then there will be only one sign change possible. This is x is odd integer, so x to the power of n plus 1 is even. So this will not change, but this will change. Okay, so you will have one sign change and that's it. This is again negative, so only one sign change is possible, which means very clear you have one negative root possible for this equation. Correct. So one negative root means you can take it. It will be correct. Okay. Descartes rule always says exact value for 0 and 1. Right. So one negative root, real root is possible. So total real roots are 1. Okay. That's the answer. Thank you. Next. Yeah. Yeah. That's all. These are the some of the questions, very interesting questions, which makes you think a lot actually. And some of these came in JEE and other competitive exams. So I choose these questions. Keep doing maths. I'll make more videos. Thank you.